The skyscrapers of New York City. They're landmarks of engineering, architectural masterpieces, and guaranteed to give you a spectacular view, especially those shiny new super talls around Billionaires Row. Sky-high pools and one-of-a-kind views of Central Park from your own private oasis in the clouds. What's not to like? Well, the energy bills for one, and we're not just talking about a few $100s a month. Some of these towers are among the most inefficient buildings in the entire city. Sure, billionaires aren't too worried about their heating bills, but towers like this are part of a much bigger problem. Right across New York, luxury high-rises gobble up huge amounts of energy right when we need to be cutting down on it.
New York City is surrounded by water. The impacts of climate change will be real here and have been real. And so what we're talking about is whether we're going to have a functioning city in the next 30, 40, 50 years.
It's not enough to just build better in the future. Lawmakers are now demanding big changes from tens of thousands of existing buildings across the city. But how do you make a skyscraper more efficient after it's been built? And what does this mean for cities worldwide? The answer could lie in a new technology that has the power to transform the way our buildings function, before it's too late. When you think of what makes a good skyscraper, the amount of energy it uses, or its carbon footprint, is probably the last thing that springs to mind. But it shouldn't be. Buildings are a leading source of greenhouse gas emissions and take energy for heating, lighting, cooling, and more. And the bigger the building, the higher these demands tend to get. That might all sound obvious, but skyscrapers in particular are major consumers. One study showed that electricity use per square metre of floor area is almost 2.5 times higher in a building of 20 or more stories, as compared to a building with 6 stories or less. In New York, the home of the skyscraper, there are many examples. And we don't just mean all the Art Deco classics, which you might think would be in need of a bit of a refurb by now. Some of them are actually doing pretty well.
The building's ambitious retrofit just hit a major milestone, reducing its carbon emissions by more than 50%.
The Empire State has just gone through a 10-year refurb which helped reduce its energy use by 40%. In fact, it's some of the glitzy towers that have popped up in the past decade that can really guzzle up power. They're some of the worst offenders. Remember 432 Park Avenue? The 426-metre tower was briefly the tallest residential building in the world when it completed. But while it ranks near the top in terms of height, on energy use, it comes much closer to the bottom. The building's Energy Star score, which goes from 1 to 100, is just 6 in the latest set of results. No, there isn't a missing digit here. Now, to give you an idea of just how low that is, most multi-family buildings in the city, in other words, residential properties for multiple households, score higher than 50. Well, a lot of it may come down to factors that are common with many modern skyscrapers. There's a lot of glass in that design, and having huge windows everywhere can mean too much heat coming into the building in hot weather and more leaking out in the cold. You wouldn't necessarily feel that inside, but you would notice it on your bill as heating and cooling systems work overtime to keep up. Then you've got elevators, which use a lot of energy to carry a car that can weigh thousands of kilos, hundreds of meters up into the air, and that's without the people inside. 432 Park Avenue has 11 of them. Similarly, it can take plenty of power to pump water up to such an extreme height, keep the ventilation systems running, the list goes on. But there's more than that because this isn't a normal skyscraper. These are luxury condos on Billionaires Row. It's got a 75-foot pool, a huge fitness centre, spa and treatment rooms, a cinema. And those are just in the communal areas. They're the types of features that are kind of expected in a building where apartments go for tens or even hundreds of millions of dollars. And yet they're all things that can really add to an energy bill. Not that the people living here will struggle to pay them. Now, we shouldn't just pick on this one building. A score of 57, the current average, isn't exactly brilliant either. It shows that tall buildings across New York, not just the most extravagant ones, have a way to go before they can really call themselves energy efficient. So, what is the city doing to get its buildings up to standard when they're responsible for over 70% of its greenhouse gas emissions? Well, New York is already taking action through a new law that's been described as the most ambitious of its kind anywhere in the world. It's inspiringly named Local Law 97, and it's going to come into effect in 2024.
Buildings over 25,000 square feet, which represent 50,000 buildings in New York City, will now have a carbon budget that they have to meet. And in 2030, that budget reduces, and then every 5 years after that, it reduces more through 2050 till we get to a net zero carbon future, reducing that enormous impact that the built environment is having on climate change.
These buildings would need to reduce their greenhouse gas emissions 40% by 2030 and a whopping 80% by 2050. On top of that, there is of course Local Law 84, which, as you'll all know, is the one that has required larger public buildings to display their energy scores to the public. That means if you get a low grade, everyone can see it, just like those food hygiene scores in a restaurant window. Some good incentives to take action then, but the big question for many is how? It depends on the building, of course, but there are a few things they can do.
Common sense things that can be done if they haven't been done already is, install LED lights. Make sure your systems are fine-tuned and operating efficiently and maintained well. Make sure your windows are sealed. Make sure your building controls are working the way they should be working.
But it can be hard to know what will make the biggest difference, and frankly, where to start. Now, there's a new type of tech that can help, and it has the potential to improve buildings everywhere. This is a digital twin. It's a virtual replica of a physical asset, which could be anything from one object to an entire building. They can be used to monitor and optimize a building's energy use in real time and to simulate what would happen if changes were made, analysing performance in loads of different ways. There are now digital twins of buildings all over the world, but it's not the sort of thing that's been widely accessible. Or so you might think. The truth, according to today's video sponsor IES, is that most buildings are already well on their way to having a digital twin. They just haven't realised it yet.
A sleeping digital twin is the process of reusing and recycling old design documents, BIM documents, and design models to create digital twins for buildings in operation. This allows you to help improve the performance, the operational performance of buildings using design materials.
Over the past 3 decades, IES has created over 1 million building models using its virtual environment software. However, these, like the many other 3D design or information models, which countless other buildings will already have, are rarely used beyond the design stage. IES is on a mission to transform these existing models into full-scale, lifetime digital assets. This is what's called awakening a sleeping digital twin. After completing an initial review of the existing model, IES carries out an energy audit of the building before data is gathered from energy bills, building management systems, and any connected devices or sensors. After this, the model is calibrated to form the basic digital twin before a live connection is established. Once that's done, the model is fully awake.
Once a sleeping digital twin is awoken, it allows you the world of opportunity to maximize the performance of your buildings over the complete life cycle of that building.
Although it's a new concept, IES has already tested it out with a company in Dublin that has a number of big buildings in its portfolio, including 2 offices, a retail unit, and a warehouse. These all had 3D models that were created in the past but had since been discarded. IES was able to take these and upgrade them before combining the information with data from the building's heating, ventilation, and air conditioning systems, and other sources like energy bills. The end result is a digital twin, along with real-time dashboards that show users how they can lower their energy consumption and carbon output. It also allows them to simulate the impact of what-if scenarios and interventions to plan their path to net zero.
We have 6 offices around the world, and we work with many of the largest architects, engineers, and building owners around the world as well. We can repeat the sleeping digital twin process internationally, regardless of what country.
So while the challenge of upgrading buildings for energy efficiency can be a lot to handle, it's encouraging that technology is becoming more of a help. And that's important because if nothing is done, the future could look pretty scary, particularly in places like the Big Apple.
And so we have to take these actions because the climate is not waiting for us. It's simply not waiting for us to act. It's going to do its thing. We have to do our part to make a difference.
This video was made possible by IES. You can learn more about that at the link below. There's also the chance to dive deeper on this and other topics on our channel over on the World's Best Construction podcast, available now wherever you get your podcasts. And as always, if you liked this video and you want to learn more about where construction is headed, make sure you're subscribed to Tomorrow's Build.